Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be going through the Configuring MAC VRF Isolated Tenants External Interconnect Learning Byte. All right, so here is our topology. We have 4 switches. We have spine 1, spine 2, leaf 1, and leaf 2. And then we have a few other devices. We have the gateway router that leaf 2 is connected to. And then we have host 1 and host 3 that is connected into leaf 1. Now, host 1 is a part of VLAN v10 with IP 10.1.1.1, and host 3 is a part of VLAN v20 with IP 10.1.2.3. And host 1 is using VNI 5010, and host 2 is using VNI 5020. And as you can see in the topology here, host 1 is connected into leaf 1 on the v10 MAC VRF, and then host 3 is connected into leaf 1 on the v20 MAC VRF. And you can see how those connections look. And then we have the v10 T5 VRF and the v20 T5 VRF on leaf 1. And those MAC VRFs then connect into the T5 VRFs so that T5 routes can be shared and connectivity can happen for them outside of their own individual subnets. And also you see here that the v10 T5 MAC VRF has the IRB 10, which is 10.1.1.254, and v20 T5 VRF has the IRB 20 interface, which is 10.1.254. And something I do want to point out here is that configuration was completed in a different learning byte. So if you're interested in that configuration, please go check out the other learning byte. And so with this learning byte, we're going to be focusing on the configuration of leaf 2. And so by doing this, we're going to configure a v10 T5 VRF on leaf 2 as well as a v20 T5 VRF on leaf 2. And those will connect in with the corresponding VRFs on leaf 1. You can see how those connections are made, or you can see how they're connected together with the topology. And this will allow host 1 and host 3 to send traffic that is destined to say something on the internet to leaf 2, which then sends it to the gateway router and can reach the internet. Now, this will also allow communication between host 1 and host 3, because that traffic, if host 1, for example, sends traffic to host 3, it'll go through the gateway router and then come back. And so we can control that traffic if that gateway router, say something like a firewall or something like that, or it could be sent to just a firewall in that regard. So keep that in mind how that works. And so with that being said, let's go ahead and jump to the CLI and get this going. All right, so here is the CLI. This is leaf 1. Now, we're not going to be configuring anything on leaf 1, but I still think it's worth our while to look at the T5 routing instances that we do have here, because that'll be very important how we configure the T5 routing instances on leaf 2. So let's look at the, I think it's v10 T5. And you can see here we have instance type, VRF, then we have EVPN configured, and we are using encapsulation VXLAN and VNI 1010. Now this is very important. That needs to match on the leaf 2 v10 T5 routing instance. So that VNI needs to match. And then we have an export policy, and that export policy is exporting the subnet, a route that represents the subnet of host 1. I'll show that in just a minute. Then, of course, we have that IRB interface. And then we have a route distinguisher that is specific to this routing instance. It's based off the loopback address of leaf 1. And then we have, after the colon, 10 for VLAN 10. And then 5 because it's a type 5 VRF. And then we have the route target. And this is important because this needs to match on the corresponding type 5 VRF on leaf 2. And that is target colon 123:10. And so then let's look at that policy. You can see here, it's just matching on that subnet that host 1 is a part of and sending that. And so what that's going to do is that's going to export that route and send it towards the T5, the corresponding T5 VRF on leaf 2. And then let's look at v20 And we'll see pretty much the same thing here, so I won't go into too much detail, but what I do want to point out is the VNI is different here. That is very important that it matches on the T5 routing instance, the corresponding T5 routing instance on Leaf 2. And then we have the export policy that is exporting the subnet that is associated with host 3. And then we have the IRB interface, route distinguisher, and then the route target, which of course must match on the other side as well. And so let's go ahead and jump to Leaf 2 and get this configuration going. So here is Leaf 2. And so let's go first. Set my caps locks on. Then let's go to routing instances, v10_t5. And so this, of course, is going to correspond with v10t5 on Leaf 1. And recall we looked at that recently. And so what do we want to do? We want to set protocols, EVPN IP prefix routes. We'll say advertise direct next hop. And then we'll want to set the encapsulation to VXLAN. And then set the VNI to, remember that it has to match with the other side. Set that to 1010. And then we do need to set an export policy. And we'll call this T5. We haven't configured that yet. So we'll configure that in just a little bit. Because what that's going to do is it'll export a default route towards the T5 routing instances on Leaf 1 that we will be getting from the gateway router. And so, but we haven't configured that yet. So then we need to set the route distinguisher. This needs to be unique based off the loopback address of Leaf 2. Say 105.10 for the VLAN, and then 5 because it's a type 5. Then we need to set the route target. And that's going to be target : 123:10. Remember, that needs to match with the corresponding T5 VRF on Leaf 1. And then we can configure the v20_t5 routing instance. It's going to be very similar to what we configured. If I can type. And then say set protocols EVPN IP prefix routes. It's going to be advertised direct next hop, encapsulation VXLAN, VNI, and this is going to be 2020. It needs to match with the corresponding T5 VRF on Leaf 1, and the export is going to be T5 again. And then we need to set the route distinguisher, and that's going to be based off the loopback address. It needs to be unique. And this is going to be 205 at the end, and then the route target going to be target : 123:20. Again, that needs to match with the corresponding type 5 VRF on Leaf 1. You can see the routing instances here, and I did forget to set the instance type on the v10t5. And so it's always good to check your configuration. And it's the instance type VRF. And so, okay, that looks a lot better. Just need to configure that policy now. And it's just going to be a simple term one from route filter, default route, exact, and then accept it. And so that's pretty straightforward. Recall that we will be getting that default route from the gateway router. So that is very important to know. Now, one thing I haven't pointed out yet is that the BGP session, there's a BGP session. I can show that. And that's in the main routing instance. And that is what is connecting to the gateway router. Well, so that's in the main routing instance. And so when routes come into those T5 routing instances, they need to be able to then, the traffic needs to be able to then make it to the main routing instance, right? And so we need to configure something to allow that to happen. And we can do that with rib groups. And then for the return traffic, we need to configure something that says to get to these subnets for host 1 and host 3, we need to go into these individual T5 routing instances. And we can do that with some static routes that point to those tables. So we'll do that now at this time. Set the static routes. 10.1.1.0/24, that's the subnet for host 1. Next table, v10 t5 and .inet.0. And then same thing, 10.1.2.0/24, so that's the subnet for host 3. Next table, v20_t5.inet.0. So those are our static routes. So that tells the main routing instance to get to these hosts, anything in that subnet, go to those individual route tables. And those are the route tables for those T5 routing instances that we configured. And then we need to configure the rib group. And so we'll do edit rib groups, and we'll just call this group 1 for lack of imagination on my part. And we'll set an import rib. We'll say from inet.0 to v10 underscore, not dot, underscore t5.inet.0, and then v20 underscore t5.inet.0. And then we need to apply that rib group somewhere, right? And so we can do that under the, go to protocols, BGP group gateway router. And so we need to apply that here at this point under the family inet unicast rib group, and we'll say group 1 for that rib group we just created. Now there's one other thing we need to do. We need to tell the gateway router about the subnets for host 1 and host 2. And so what we can do there is, now that we have those static routes, we configure those static routes, that those routes are going to be in the main routing instances. And so we can just create an export policy that exports those routes to the gateway route. And so we'll set the export here. We'll call this MAC VRF T5 for the policy. And of course, we haven't configured that policy yet, so we need to configure it. So let's go ahead and do that now. So I call that MAC VRF T5. And what we need to do there is we'll set term 1 from route filter, and that's going to be 10.1.1.0/24 exact. And then for the subnet for host 3, and then accept the routes. And that will advertise the routes to the gateway router for the host 1 and host 3 subnets. So that does bring us to the end of this learning byte. In this learning byte, we demonstrated how to configure isolated tenants, that is layer 2 and layer 3 isolated tenants, with an external interconnect with MAC VRF in a data center. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.